Hello and welcome back to Mr. Powers Teaches Algebra. Oh, so what are we doing today? Today we're talking about rationalizing. Hello? There we go. No? No? Rename? Jeez. Rationalizing the denominator. So when we say rationalize the denominator, we're meaning that the denominator is not rational. It's getting mad at you for no reason. It should have a good reason, but it doesn't. And it doesn't matter. You're just going to have to figure out it and deal with it. So let's rationalize it. We got to make it rational again. Or it means there's a root in the denominator that we cannot simplify. And those roots that we cannot simplify end up being irrational, which means you can't rewrite them as a fraction of integers. That's what it means. So anyway, we want to get rid of the roots in the denominator. We'll just leave it at that. So how do we do that? Well, first things first, I want you to remember here that if you have a minus b times a plus b, first of all, a minus b and a plus b, these guys, we call conjugates, okay? That's an important word, conjugates. A and b stay the same, one's a minus, one's a plus in between them. Those are conjugates of each other, okay? And it's a neat result happens whenever you multiply conjugates. You get the difference of those terms squared. You get a squared minus b squared. And a lot of you might know this as the difference of squares when we're talking about factoring. I have a difference of squares. If I start with the right side here, I can easily write it as the left side. We're going to go the other way, though. We're going to say, hey, we're going from here to here, and we want to take a shortcut. So, for example, if I had, I don't know, let's just say root 2 minus x times root 2 plus x. If I multiply those conjugates, I will get what I have up here. In other words, I get root 2 squared minus x squared, which of course is going to give me 2 minus x squared, right? We can multiply it out, but that's a fact. We already know this. So rather than show all the steps, when we have a difference of, when we're multiplying conjugates, we know we can go straight to this result. If you're not sure, test it out yourself and see what you get. The last video I posted did exactly this kind of multiplication. So we already know this. So this is really nice because what you'll see is, remember, we're talking about rationalizing the denominator. What happened to my roots? I started with two binomials, two expressions that had roots in them. I multiplied them, and my result, no roots. That's very interesting. Okay, so we want to rationalize a denominator. Let's see here. Let's see which examples I'd like to do. Let's do an easy one first. No, let's do a hard one first. I like the difficult ones myself. So let's say I want to do 1 over 3 minus root x. I want to rationalize that. Now, remember, we got this property. We're talking about fractions, and this is nothing new. And that is, if you have a over b, we can multiply top and bottom by the same thing, and we get an equal result. It's going to look different, but it will have the same value. And that's what's really nice. So that's exactly the trick we're going to use. We're going to multiply the top and bottom, numerator and denominator, by the same thing. Well, what is that going to be? It's going to be the conjugate of the denominator, because I don't want the root in the denominator. We want to rationalize the denominator. Remember, that is what we're doing. Rationalize the denominator. Okay. So I'm going to do that. What's the conjugate of 3 minus root x? It is 3 plus root x. So whatever I do to the bottom, I must do to the top. We're talking about fractions if I don't want to change its value, just the way it looks. And what shall we get when we do this? We will get, well, 1 times anything is that. So we get 3 plus root x at the top. And in the denominator, we're going to get the first term squared, so 3 squared, minus the second one squared, which is going to be our root x squared. And we can simplify it, make that look a little nicer. 3 plus root x all over 9 minus x. And that would be our result. We have rewritten our original expression, which was in purple here, into this one that's red. And now, no more denominator. If you stick these in a smart calculator, a CAS, like GeoGebra has a CAS mode, or Symbolab, and you subtracted the purple expression and the red, you would get 0. Okay, Wolfram Alpha also. These are ways you could check. Say, are these really the same? Very easily we could do that. That's one way we could check with technology. Okay, so let's do another one. Now, we always do this, and then people like get stuck on this guy. So what if I had something like this? What if, oh, so smart. What if we did 4 over root x? Same thing, we're rationalizing the denominator. What's the conjugate of root x? Now, I could say, if I wanted to, root x is the same thing as root x minus 0. Okay, so what's the conjugate of that? The conjugate of that is root x plus 0. So anyway, what really are we doing here? Remember, we just want to get rid of the roots. And this is a single term. So we can be a little bit more creative here and just say, hey, if I multiply a root times itself, there's no more root. And that's what we're going to do. And we can see that here even with the conjugate trick. That, you know, what's root x plus 0 is also root x, right? So root x times root x, so I'm going to multiply top and bottom here by root x. Now we get 4 root x over x. And that would be our result. Very easy, very straightforward. Okay, now let's do another one. Let's see how tricky we can get. I think this would be the best one to do, and I think we'll probably be in good shape. I can do one more, but I'll say it's completely optional if you want to see it or not. We're going to be coming up here on 10 minutes for this video. So 1 over, here's our next example. Okay. There we go. It must be a setting in OneNote I need to fix. So let's see here. 1 over 3 no. I don't want to do 1 over. What I want to do, I apologize. What I want to do is the 5th root of 2 over x cubed. This is going to require more work, surely. And so with this, we're like, well, the whole thing's under a root. Let's get the denominator and the numerator clear, right? So we have this property that we can split this root up between the numerator and denominator. So I'm going to rewrite that first things first so that I can focus on my denominator only. Because right now it's stuck in this root. The whole fraction. I can't just look at my denominator. So we got the 5th root of 2 over the 5th root of x cubed. So now, again, I got to be more creative, kind of like I was, up above. I got to be like, well, how am I going to get rid of this root? I want it gone. And I'm going to use this little property we have, that the nth root of x to the n is x. That's what I'm going to do. So I have 3 x's under the root. I want 5 of them under the root. So that's what I'm going to do is multiply numerator and denominator by the 5th root of x squared. Because that will get me my desired result. That's going to give me x to the 5th under the root. So whatever you do to the bottom, I'm going to do to the top. 5th root of x squared. And we get, on the top here, the 5th root of 2x squared all over the 5th root of x to the 5th, and we already know those cancel each other out. So I finally get to write it without the root. 5th root of 2x squared over x. That's going to be my simplified result, my rationalized denominator result. And that should do it for us. That should make it really clear what we need to do in these guys. Remember, we're trying to get rid of the roots in the denominator. All right? So I hope you find this useful. Until next time, have fun doing math.